Let's go ahead and take a look at a more complex rule of 70 application using Futurama, one of my favorite shows. So let's go ahead and take a look at this video.
Do we have enough money to pay Bender's fine?
78, 79, 79.50. Crud. We're 50 cents short.
I'd love to chip in, but Bender stole my wallet.
Hey, that's my old bank. Maybe my account's still open.
We don't seem to have your retina scan, your fingerprint, or your colonic map on file.
Yeah, well, I did open the account over 1,000 years ago. What about my ATM card?
Do you still remember your PIN number?
Sure. It's the price of a cheese pizza and a large soda back where I used to work. Panucci's Pizza.
Okay, you had a balance of 93 cents.
All right.
And at an average of 2.25% interest over a period of 1,000 years, that comes to $4.3 billion.
So I'm pretty sure that the vast majority of us would be like Fry in this situation if we learned that we had that much money in our bank accounts. So let's use a few of the numbers that we saw in this video right here to apply the rule of 70. So what was the interest rate that we saw in terms of the bank? It was 2.25%. So using the rule of 70, 70 divided by 2.25, 2.25. That just is going to tell us that it's going to take us approximately about 31 years. Let me write that better. 31 years for Fry's money to double. So 31 years. How long of a time period were we looking at? Fry said that he opened the bank account over 1,000 years ago. So we want to see exactly how many 31-year time periods there are in 1,000 years. So additional question is, how many 31-year time periods, or just 31-year periods, are there in 1,000 years? Are there in 1,000 years? So based on the rule of 70, we notice that our money is going to double every 31 years, but we're working with 1,000 years. So in order to see how many 31-year time periods there are in 1,000 years, all we need to go ahead and do is divide 1,000 by 31, and that'll give us approximately 32 periods. So 32 periods. So Fry's money is going to double 32 times. So with this information in mind, we can go ahead and figure out how much money he should have based on the rule of 70. We had a starting value of 93 cents, 0.93 in his bank account. Sort of looks like my bank account as well. And his money is going to double 32 times. So here, 93 cents times 2, because we are doubling his money, and his doubling is going to happen 32 times. So here, if we want to do this over a very long period of time, we can raise the doubling value right here to the 32nd power. So 93 cents times 2 raised to the 32nd time period. When we do this calculation on the calculator, we get roughly about $3.9 billion. So $3.9 billion. According to the rule of 70, if we have 93 cents in our banking account and we're doubling our money for 32 time periods, and it's going to take us 31 years in order for our money to double, we roughly have about $3.9 billion. And in the video, the value was $4.3 billion. So once again, it gives a pretty good approximation of the actual value. So the writers at Futurama, they're actually really, really smart. The vast majority of them actually do have advanced degrees in mathematics, physics, and economics. So one of my favorite shows, and we can see a little bit of the application with the rule of 70. We'll wrap up the rule of 70 with one more example that we can take a look at, and that's going to be the focus of the primary concept here.